Hello, everyone. My name is Ian McLeod, and I am Executive Vice President and Chief Product Officer of SmartBear Software. I am very happy to be able to welcome everyone to the next installment of SmartBear's ongoing series of quality webinars. We have a very exciting topic today. We are privileged to have Jim Sartain, Senior Vice President of McAfee, with us to share some of his thoughts on inspiring, enabling, and driving quality improvement. I'd like to take a minute to give a little bit of an overview of Jim's impressive background. Jim is the Senior Vice President for Quality at McAfee. Jim is responsible for inspiring, driving, and enabling continuous quality improvement across McAfee worldwide. Prior to McAfee, Jim was the Senior Director for Quality at Adobe Systems in a similar role. Jim's leadership there enabled Adobe to deliver major new releases of Creative Suite 5, Acrobat 10, and other major product lines with higher quality, engineering agility, and efficiency. Prior to Adobe, Jim held quality and process improvement and product development positions at Intuit and Hewlett-Packard for 25 years. While at Intuit, Jim drove significant customer experience improvements for QuickBooks, Intuit payroll services, and other major products. His last role at HP was the CTO-CIO for an airline systems business that supported major low-cost airlines. Jim earned his bachelor's degree in computer science and psychology from the University of Oregon and his master's of science in management of technology from Walden University. Today, I'd like to run through the agenda. I'll have a couple housekeeping things, and then Jim will take us through his presentation where he'll cover the hidden costs of quality, quality tips and techniques, the importance of defect discovery, and McAfee's 4-step quality improvement strategy, top defect discovery and removal tools for distributed teams. At the end, we'll have a question and answer. We'll get to as many questions as we can with the time at the end of the webinar. If you have questions during the webinar, please submit them at any time using the questions feature on your GoToWebinar panel. We encourage everyone to share the event on Twitter. We'll conduct a follow-up session using the same hashtag directly following the presentation. And there will be an on-demand replay. The recording of this event will be available within 24 hours following the event, and there'll be an email with instructions on how to access the recording. With that, I'd like to turn things over to Jim to tell us about inspiring, enabling, and driving quality improvement.
Great. Good morning or good afternoon, wherever you're at, or good evening possibly. Thanks for making the time to participate in this discussion. We have time for questions later on, so I really want this to be an interactive thing. I'm going to try to get through these slides in about 40 minutes and leave at least 10 or 15 minutes for questions. So let me first talk about McAfee a little bit. You've probably heard about McAfee. I've actually been around the world. McAfee has many locations, and I've yet to meet anyone that doesn't know the name of the McAfee company, but we basically protect hundreds of millions of users, major enterprises, including governments, the Department of Defense for many countries, major banks, major organizations around the world. So it's a pretty, quality is of the utmost importance. What our customers expect of us is that we provide protection while never impacting their business, and so that's what we do. The quality is very important in McAfee. Let me talk a little bit about how we assess quality. We use the Net Promoter tool. We very frequently ask our customers how likely they are to recommend our products or services to others, and our goal is to have a vast majority of our customers be what are called promoters, where on a scale of 0 to 10 they would rate us a 9 or 10. You want to have very few detractors, folks with lower scores on this question. So we regularly survey our customers. We regularly even have meetings with our customers where we use this tool. And the next most important question besides the first one of how likely are to recommend is what could we do to improve the product experience that would cause you to be more likely to recommend? And by relentlessly focusing on the things we do well and the things we can improve, we're able to drive continuous improvement in what matters most to customers. The goal here is that all of our customers would be promoters, and the job of our sales folks would be very easy because our best salespeople would actually be our customers. So our goal is to actually have 70% of our customers be promoters. That's a world-class net promoter score. If you have 70% of your customers 9 or 10 on a scale of 10, very few detractors, you're doing really well. We also need to solve for our employees. What I'll be talking about today is things that we do to improve the customer experience and also improve the employee work environment. We have some awesome engineers, and many of them have, all of them have, really great innovative ideas. We need to make sure they have time to spend on innovative work and not just on fixing defects. And so much of the effort that we go here has a threefold win, actually. It not only improves the customer experience, it frees up valuable time so employees have much more time to spend on innovation. In fact, our goal is to double the amount of time that the employees have for innovative work by basically eliminating reducing defect-driven rework. This will have a great benefit for McAfee's shareholders as well. If we've got extremely loyal customers and employees that have lots of time for innovation, then you just can't miss. Trying to change the screen here. Let's see here. Not working. There we go. So I talked a minute ago about the shareholders. One way to think about your issue with cost of quality issues is to think about quality. The parts you can measure is the tip of the iceberg. And this slide is not about global warming. This slide is about the fact that if you measure the amount of cost that you can attribute to quality issues, things like tech support calls, things like engineers having to fix a defect that's been found by a customer post-release, it can consume a significant amount of your budget. In fact, I've benchmarked some companies and found some that spend up to 40, 50% of their engineering effort on an engineering rework. And what I mean by engineering rework is, I mean, finding a defect. When a customer finds a defect, it's much more expensive to deal with than if it's found early and efficiently through world-class engineering practices. The same goes for tech support. Tech support predominantly is dealing with issues. They may be defects that cause reliability issues. They may be simple usability issues or just confusing products. This is basically an opportunity because an example is many companies like McAfee, Adobe, etc. may spend hundreds of millions of dollars on tech support. You can dramatically reduce that expense and improve the customer experience by improving quality. So the idea here is that we want to improve quality. It's a big opportunity to free up time for innovation and free up, make the company more competitive. Let me talk next about our strategy. First of all, it has to start with the engineering leaders. It has to start with the development managers, the people in charge of the development programs. They have to know that it's expected that they deliver high quality, predictably, efficiently, with an effective work process. And we are, it's actually the time of year right now that McAfee is starting to do its annual review process. And we're making sure that this is a key part of the review criteria. If it's not part of an engineering manager's responsibility, if they're not held accountable for this, they often will fail to provide the environment for their people to do the work. And I've done classes all around McAfee sites. I teach often, and I've been around the world, and I've never found an engineering population that wasn't really interested in delivering higher quality work. The biggest predictor on whether they're going to be doing that is the level of support they get from their senior management, their engineering leaders. And so we start with that. The second thing we say is that every release must be measurably better than the last. And so even if we've got a product at McAfee that's the best at McAfee, the expectation is that that release, the next release that they do, will actually be measurably better than the previous one. And so that's how we drive continuous improvement. It's not about comparing the quality of product A to product B. It's about expecting that if you own product A, you're going to make product A version +1 better than the previous version. The way that we do that is each project at the onset sets a set of quality goals, plans, and we have regular reviews with senior leadership. I just had one this morning where the format of the meeting is quite simple. We might have, say, 8 projects in a business unit. We'll go through each one for just 10 minutes, and the team leader will talk about, here were the quality goals we set, here's how we're doing on them, and any commentary on whether they're exceeding their goals, if they're not meeting their goals, what's the problem, what are they doing about it. And this review has a couple purposes. One is I've seen leaders get on board when they see what's possible, because when they see a peer organization able to achieve pretty significant improvement in an area like the percentage of defects they find in peer reviews, then it becomes undeniable that this is something that can work, especially if it's a team that's much like your own, within your own company, within your own department. And it also just it's a moment of truth where each leader is accountable to everyone, to their peers, to their leaders, to their team, to come out and say, you know, this is important, this is how we're doing, this is the progress we're making. So that's a key lever. So here, I guess, timing out. Next slide. Okay. We're using a viral approach to driving adoption of best practices. It just doesn't work to come out and pronounce and say, for example, I tried it, believe me. I once ran a large engineering organization of 200 people, and my staff and I all had this brilliant idea of let's get everyone in the organization doing formal inspections. And this was a great idea except for one thing. Simultaneously convincing 200 people and, say, 10 teams, 20 teams to do this simultaneously, very tough. But what we should have done, and what I do nowadays, is I tell everyone about it, and I find some teams that are interested in doing it, and I help them, make them successful, and promote their progress and get them the kudos that they deserve for driving improvement. And so once they become successful adopters, they're innovators, and they will encourage others to adopt, those early adopters, and then you just, over the course of a few years, you can go from having a practice rarely used at a company to having it used in a majority of the company. And most importantly, it's done effectively. My experience has been if you mandate a process improvement, it usually doesn't work because people that are convinced that something won't work have an amazing ability to prove that true. Whereas if you start with people that think it just might work or believe it'll work, you can make them successful, and then over time, you start getting effective adoption. So you have to be really careful in what you do with metrics, and that's another thing you can go wrong on, is if you start incenting an organization and saying, we're going to measure you on X, especially individuals, you can get some really perverse behavior. I remember one organization that was measuring its QA automation people by the number of test cases automated per day. And they did this for several years. And the automated test suite blossomed to 30,000 test cases. And then when I took over this program, the first thing we had to do was throw away 22,000 of those cases because they were redundant or useless. We started instead incenting the team to improve code coverage and reduce the amount of effort that it took to run a full regression test. And so those two metrics were better measures, but the team, we asked the team where they were at, what was their baseline. We asked the team to set its own goals. And having a team-based metric where the team sets its own goal, you can get the right kind of thing. If you start having an individual metric on people, either unintentionally or intentionally, you often end up with the wrong outcome. And this is what this, of course, this classic Dilbert cartoon illustrates. This data here talks about the relative effectiveness, efficiency of different removal techniques for defects. This is actually data I've gathered from 4 different companies now, and it matches the data I've seen in other industry surveys. Basically, there's an order of magnitude increase as you go from an individual finding their own problem to a team finding the problem in a system test or QA test to a customer finding this problem. This is a well-known phenomenon. You've probably all experienced this. But this is actual data. We're finding, on average, it takes about 1 hour to find and remove a defect that's found in a personal review or a peer review. So peer reviews are a cornerstone of any defect removal program. And the other thing that happens is as soon as you start doing peer reviews, we notice that there's this magical thing that happens. People start looking at their own work before they even submit it for a peer review. So the bar gets raised twice. It gets raised once because the initial quality increases because people's professional pride causes them to take another look. Many of you can remember, maybe taking a standardized test and remember what you did if you finished a little bit early and you went back and said, well, I'm going to check out, a few of these questions. You might just have found an error and been able to correct it. It turns out that if people really apply, we're not talking hours here. We're often talking minutes. If people just take 15 minutes to 30 minutes to carefully look over something, they will very frequently, we think about half the time, find a problem. So we're talking about 1 hour of time invested to find and remove a defect where you know exactly where the defect is because you basically take a look at a line, you see the line that's incorrect, you know how to fix it. If you take the scenario where a QA person or some other person finds a problem, they basically find a symptom. They don't actually find a defect. They find basically a bug report. The first thing that has to happen is they have to isolate, duplicate it. The person who gets it has to play Sherlock Holmes and try to find out why that's failing. They then have to correct the defect. So it's anywhere from 8 to 10 hours on average if it's found in system test. And then if it's found in customers, we're just estimating an average of 40 hours of employee time. That doesn't even take into account the customer impact, right? This is just this cost to quality example. That's just the tip of the iceberg. That's the McAfee or direct company cost of finding a defect versus it doesn't take into account the true total cost of quality. So what we call the defects that are found through these methods like personal peer reviews or unit tests, we call those found early. We don't mean like early in the life cycle. We just mean early, meaning close to when the defect was injected. We call it late when it's found in a downstream process. The code's been checked in, somebody else finds it, reports it, and we call it too late if it's found by a customer. So the cool thing is that these early and efficient defect removal techniques are actually improving both quality and productivity. Let me give you an example here. I've worked out a hypothetical scenario here, two scenarios. One where a team doesn't do personal reviews or peer reviews. They do some unit testing. The yield percentage is basically of the defects that existed at that point, how many were found in that process. I start with a hypothetical situation of 5,000 defects existing. If you go look through the math, you'll find that, and we assume that customers will only find and report half the defects that exist once it gets delivered to them. You'll see in scenario one, where there's little attention put on personal reviews or peer reviews, no, actually, and not as much unit testing, you end up with the customers encountering 250 defects. If you look at the total effort using those numbers I showed you on the previous slide, the total effort is 24 people worth of effort, 24 FTE, full-time equivalents. If you compare scenario 2, where you're using all of these methods, and these 50% yield, or finding 1 out of every 2 defects that exist, is a reasonable goal. We're seeing many teams that actually exceed that. You get down to only 75 defects found by customers with a total effort of finding and removing of 6. And so you basically have a 4-fold reduction in work while you have a significant improvement in quality. So this illustrates that applying these techniques effectively improves both quality and productivity. So this is another example. I worked with some teams at Adobe that actually measured their time, the time that they invested in all their early defect removal techniques, and they measured the percent of time that they spent in development, post-development tests, basically QA testing. What you can see is that they were finding an average of about 80% of their defects early, and they were only needing to invest about 16% of their time in post-development testing. What this basically means is, again, there's total cost of quality. If you take the effort on the proactive side of doing all the work of peer reviews, personal reviews, unit testing, plus the post-development work of fixing bugs, they were averaging around 25% total cost of quality, whereas the average team was requiring at least double that much time, while they were finding far fewer defects early, which the consequence of that is that customers would find far more defects later. So one of the key things I mentioned using a viral approach, what I do is I survey the people doing peer reviews, and the predominant method for doing peer reviews at McAfee is using the Code Collaborator tool. And so what I do is I periodically survey the users of the tool. We have their emails. We send them an email. We ask them how likely they are to recommend doing peer reviews. And as you can see, almost half are 10, more than half are 9 or 10. You've got a fair number that are 8. So very nice distribution here of very positive people. And this is everyone doing these things. So we said you get a survey if you've done a peer review in the last 30 days. And so this is because we followed this viral approach. Now, this viral approach has been successful because we've actually doubled the number of active peer reviewers over the last year. And we've seen the number of concurrent sessions go up by 2 or 3x as well. We've seen the number of defects being found going up by 2 or 3x over the last year. And we're now at a point where we have about 60% of the engineering population regularly using the Code Collaborator tool. There are some others that use other peer review mechanisms. Many teams are using both. So the scenario where, particularly where the Code Collaborator style peer review is helpful is we have some teams that are distributed where they have, people in maybe Paderborn, Germany, Aylesbury, England, Bangalore, India, Beaverton, Oregon. If you've got a distributed team, it can be quite effective for the developer to fire off their review and then go home, basically. They might fire it off at the end of their day, and then maybe by the time they get back in the next day, they've had some peers that have given them some feedback. So that's how that works. This chart just showed that first 6 months, 7 months, we've seen this trend continue. We continue to, and so like I said, we're at about a 60% adoption rate at this point. The consequence of all this is we've seen a reduction in the number of defects found by customers year over year. This is despite the fact that McAfee continues to grow. We have more products, we have more customers, we have more customers using more products than they used to, and they've expanded their use of the portfolio. We've seen fewer technical support calls, a significant reduction, and we've seen an increase. We do this Net Promoter Survey every month. We've seen an increase in customers' likelihood to rate McAfee product quality as excellent, very good, as well as their intended likelihood to renew, buy again. The percentage of customers with excellent, very good rating have increased over the last year. We've seen, by the way, you saw an improvement from 2010 to 2011, and now we're almost on the halfway mark for 2012. We're seeing an additional increase in these results as well. Let me turn it over for questions.
Okay, thanks, Jim. We certainly appreciate your sharing your expertise with us. That was a lot of great insight and practical information on improving quality, driving change in organizations, and it looked like you drove some great results at your organizations. So there's still time to ask questions, so please type your questions into the GoToWebinar panel. And we take a look at the first one here. So Jim, the first question we have is, in the 2 defect removal process scenarios, you show greatly improved total effort due to the reduced customer defects. Does McAfee use some sort of means to apply the cost of poor quality back to the project such that it encourages project managers not to make the expedient choice of cutting corners to stay on budget?
Yeah, so for every release, as it's initiated, the leaders have to declare what their specific improvement targets will be. And those are measured every month in a leadership review meeting where, again, the projects are comparing actual to plan. So they actually forecast the number of defects that they expected to find early and how many they expected to find late. And we found those to be excellent predictors for how many that will be found by customers. And so a typical goal might be we're declaring that our intent is to find 30% fewer defects post-release. And the way that we're going to get there is we're going to adopt peer reviews, and we're going to find 40% of our defects in peer reviews as percentage of the total found during development. We're going to implement automated code coverage of a 70-80% level. And so those goals are set at the beginning, and those goals are looked at retrospectively. So after 6 months and 9 months, we do go back and look at the projects and see how they turned out. And we do hold the leaders accountable. In fact, like I said, we're doing this annual review, and so as part of an annual review, every leader has to declare how they did, how did it come out. And those are metrics that can't be gained because the customer-reported defects, number of tech support calls, et cetera, customer loyalty, those are all collected by our tech support department. So there's just no way around it. That's your final report card.
Thanks, Jim. Okay, the next question is, every release must be measurably better than the last. How do you do this, and what are the major pillars involved in the activity?
Well, so based on the Net Promoter Paradigm, you ask customers what's most important, and you ask them what is most in need of improvement. And it might be you pick those things that matter the most. Let's say you have a product and the customers tell you it does a great job of detecting malware. However, we want it to do that while consuming less computing capacity. So you might set a goal that says, our goal is to be able to do a full system scan with 80% less CPU. And you set that as your goal. And so basically the goals will vary by product. There are a few goals that are in common. We are setting a goal for every product that they will be more reliable than their last release. By reliable, we mean there will be a reduction in customer-reported defects. We have some really high-quality products. And that said, we still want to continuously improve them because our goal is to relentlessly drive to zero or near zero for customer-reported defects. I hope that answers the question.
Okay, next question says, thanks for the seminar. Any thoughts on the use of static code analysis software during peer reviews?
Yeah, we make very heavy use of static analysis. We use a couple of major tools. And that is also part of the early defect removal practices. I probably should have mentioned that. We don't have quite as clear we don't have quite the clear metric in terms of the cost per defect. But, I've been following those tools for 20 years, and I used to think they used to be actually not very useful because they would have so many false positives. We're now having some fairly good experience with at least one tool. And so we're making that part of our standard, approach to early defect removal. Now, what we do is we have teams set those up, and they often do that as part of their check-in process. They would certainly do it as part of the weekly build process, but basically, that's a great lever. Glad you mentioned that.
Okay, thanks. Next question is, how would this work within an Agile Scrum software development lifecycle?
Yeah, the way that we have about maybe 20% of our teams at McAfee now using Scrum, and we're driving that. We have a big initiative starting this year where we're going to drive over the course of probably 3 years. We'll have 80% of the teams be using Scrum. But the way it works is the teams that are doing Scrum make their these early defect practices part of their definition of done. So a developer will say, if I'm implementing this story, the code isn't done until I've created automated tests, unit tests that are part of it that basically test the code that I've just written. And a personal review would be part of the definition of done. Also, a peer review, and again, that's one of the other benefits of the code collaborative style review is you can fire those off, and you don't have to have the team have a big lag while you're waiting to set up a meeting. Now, I'm a big fan of in-person inspections reviews. But we use those predominantly if we're writing a big, huge chunk of new code, or we have an area of code that's really problematic. It's much more common for incremental changes to software to be peer reviewed through Code Collaborator. So basically, again, that's the definition of done for many teams. It's just unless there's effective peer review that's closed out, the feature's not done.
Okay, the next question is, how large of an automation staff do you have to achieve the 80% coverage level?
Well, to be clear, we don't have 80% coverage level in all products. It really varies from team to team. I don't know quite how to answer that question, because the other thing we're shifting to is automation is not just the job of QA. It's the job of the team. And so the team sets a goal to achieve the target level of coverage with, and this is very important, with a effort. You measure the effort. So how much time does it take a person to execute the test and triage the results? Because if the tests can't be run in a matter of just minutes or hours of effort, then they require significant improvement. It can't be days or weeks. So it's a team goal, and so it's not really, it's kind of hard to answer that question both because it varies across teams across the company as well. We're looking at it like it's no longer just a QA responsibility, but it's basically a team. By team, we mean dev plus QA plus everyone else involved in the development effort.
Okay, next question is, how reliable are the metrics for defects found in personal reviews, peer reviews, and unit testing? Do developers have the discipline to record these results?
The key to metrics is they need to be directionally accurate. We periodically look at the actual defect logs and see occasional anomalies where we've got a definition of defect. We ask people to declare a defect as being something that would be in code, that would be something that would cause the code to malfunction in a very specific way. We sometimes see people logging defects as comments. And sometimes they log comments as defects. So it's a matter for the team. What actually works pretty well is if the team is looking at its own effectiveness metrics, and so there's two metrics that matter, efficiency and effectiveness. If you look at the number of minutes to find a defect on average, we're finding that should be around an hour. And if that number is much lower than that, either the code that's being reviewed is far too defective to be reviewed. It should have been much better shape before the review entered, or maybe people are calling things defects that shouldn't call defects. So it's a continuous improvement process where people look at their team metrics and they examine what they're actually calling defects, and there's some refinement as teams go along. So it's really up to the teams to make sure that their metrics are squared away. And because they're using them to achieve team goals, there's a lot more involvement. It's not just an individual's opinion.
Okay. So Jim, who on your team has the responsibility for drafting quality goals and plans in the product lifecycle?
We have a role at McAfee called a quality leader. And I'm the quality leader for McAfee. I've got quality leaders for each major business unit. I've got quality leaders for some products. It's the job of a quality leader to help the team, including the development manager, including the whole team, basically come up with what they think their goals should be. And it works best for teams to declare goals for what they think is possible. For example, we never tell a team, thou shalt find X% of your defects in peer reviews. We do share data that shows that there's teams that are finding up to 70%. The average, is probably 30, 40 right now. And so when a team, says, hey, we're going to find 3%, you can say, hey, have you noticed that it seems to be possible to be doing much better than that, in fact, 10x better than that. Why don't you go talk to these other teams over here and ask them, what they're doing, how they're doing this. And it's so much more credible when it's another development team that's saying, yes, this is how it works, this is what we're finding. You want to have that positive reinforcement. I'll just give you an example of some comments. I just taught a peer review class in Idaho Falls last Friday, and you want to have comments from the engineers, having them say things like, I was a skeptic, but now a believer. I sincerely hope we implement this practice. So this was a class that's taught on Friday, and so this week they're starting to do these things. You really want people going in that really want to give it an honest go. And you have to answer those hard questions. There's plenty of great questions, reasons that people could be skeptical. But the number one reason I hear for people being skeptical about this stuff working is not because they don't think they can do it themselves. It's because they question whether they're going to be given the time to do the work. And so the best way around that is to also set a goal not only on the number of defects found, but set a goal about the amount of time that's set aside for doing reviews, the amount of effort basically, and track the effort actually invested versus the effort plan. And because what we're finding is when teams are not finding a high percentage of defects in peer reviews, it's only because they're not investing enough effort. I'll give an example. I found a team that was only finding 8% of their defects in peer reviews. So I asked them how much effort, and because they were using the Code Collaborator tool, it tracks the effort, they found they were investing 15 hours a month in peer reviews. And I asked how many people on the team, 25 people. So then I asked, well, how much time is that per month per person? I mean, you know, work it out. That's less than 30 minutes. So how much time per person per week? That's 7 minutes. Okay, I think we found your problem. I mean, try investing 30 minutes a week or an hour per week per person. See what happens. And sure enough, they're starting to see a significant increase in the amount of defects found in peer reviews and the overall percentage. So a very effective metric is percent of defects found in peer reviews as a total of the total found in peer reviews plus the total found in testing. And so a reasonable goal for an initial team is at least 20%. But most teams are able to work up to 50, 60%. So if the team measures the percent found in peer reviews plus they budget, if you're going to find 100 defects at an hour per defect, then the team should be investing 100 hours of time. If they've only invested 10 hours of time, then they're going to only find 1/10 as many defects, right? I mean, it's simple. So, sorry, long-winded answer to your question, but I hope that was helpful.
Okay, the next question is, what is the main reason for defect leakage in any product, and what is McAfee's strategy to prevent defect leakage?
Well, think about it like a water filtration system. The way that it works is you need to have multiple filters, each filter making the water cleaner and cleaner. And when you are doing person reviews and peer reviews and developer unit testing and static analysis, if you apply those 4 filters, you can already see an 80–90% reduction in defects found in tests. Then you apply world-class testing. If you don't apply those 4 filters and you apply world-class testing, then you're basically not going to be at a world-class quality level. So it's a matter of applying all of these filters, doing it well, and that's how you can deliver world-class quality.
Okay. Next question, what are some ways that you might suggest to incentivize developers to adopt peer reviews?
Well, again, you want to incent the team, and basically, well, first it starts with the leaders. The leaders need to feel like it's their job, basically, to deliver high quality, and they want to provide the environment where their teams say, yeah, I've got the environment. It turns out that most engineers are motivated mostly by wanting to do great work, and the best incentive for them is the fact that if they do this stuff well, they will not have as much drama in their lives. They won't have as many of these instances where they end up having to work late night, weekends. They'd rather be writing some cool new code than fixing a bug. They'd want to deliver a high-quality product that customers really love. So there's all kinds of intrinsic motivations that are at play, and that's what you basically will sell the engineers on, is this is how your world will be better. I use one metric at one company. We measure the amount of catering that was brought in to feed the engineers for dinner. And people actually didn't like that. They were tired of the dinners. And so we went from 1 year spending $30,000 in catering to the next year we spent $50,000, and that was a big win. I mean, people didn't have to hang around for dinner. It was expected that during the crunch time that 4 days a week in this one organization, people were there for dinner. And the next release, that wasn't necessary. We had one basically push. One team came in one weekend, and we brought in some pizzas. So I called that the pizza slices served metric.
That sounds like a good metric. Next one is, what is your strategy for peer reviews? Are these done by members of the same development team or by other teams? And are the peer reviews limited to functional review of software, or does it involve a review of source code as well?
Well, it's all the above. The peer reviews can involve requirements, design, code, test plans, test cases, and as far as who to select for review, the optimal review team is from 3 to 4 people. We found that gives the most efficient use of time. You get more than 4 people and you start having diminishing returns in terms of number of defects found per hour of time invested. If you only have 2 people, then you don't have the same level of effectiveness. So you pick those 3 to 4 people based on, it's often helpful to have producers and consumers involved. If you're writing an API that's used by somebody else, involving someone from the team that uses your API can be a good idea. It's a great idea to have, if you've got QA people that read code, it's a great idea to involve them. They can make a contribution even earlier by helping find defects real early, like by reading the code. They get a better idea how the code works and they can get new ideas on how to test it. It's often valuable to have a novice. There are a couple advantages of novices. Novices often ask questions that the experienced people might gloss over, and those turn out actually sometimes to find problems. Sometimes their questions don't actually find the problem. They cause the more experienced people to think about something, and that in turn causes them to find the problem. So you basically want to craft the teams. You can't have all novices. The people that in the review need to at least be able to read the language, of whatever the thing that's being inspected is written in. If it's code, they should be able to read, proficient in reading that language, basically, so they're able to read the code, basically, or read. So those are the only requirements I can think of.
Okay. Next one is, sounds like it's about a project that already has quality problems. So the question is, how do you decrease the cost of maintenance, meaning issues from customers, if the count is already very high? What should the allocation be in terms of project QA and maintenance QA in %?
Well, it's hard to answer that question exactly, like what the ratio should be, because it depends on a lot of factors. It depends on the quality of the automation that exists. It depends on, like you said, the quality of the code. My biggest recommendation is, if you've got a product with quality issues, do an analysis of where the issues are, what the root causes are, and what areas of the product are most problematic. You can often find that there's 10 modules that are producing 80% of the defects. You might even want to consider re-implementing those modules, or at least you can focus your unit testing and your peer reviews on those most problematic modules, because you'll find an even higher number of defects early. If a project's in trouble with quality, you'll really have a tough time getting control if you're just following a test and fix cycle, because of the economics. If it's so much more expensive, 10 or 12 hours per defect to resolve a problem, and you just go on and on, the cycle goes on and on. The way to break that cycle is to go ahead and bite the bullet and say, we've got to invest some time to eliminate some of these key areas. It's like doing chemotherapy on a cancer. You basically have to root out what parts of the product are most problematic and just get and fix them economically. Otherwise, you'll probably be in a constant churn of test and bug fix for an indeterminate amount of time.
Okay, the next one is related to offshore software maintenance projects. And in this case, the offshore team just performs bug fixes in the application. And the schedule and priority is driven by the customer and customer bills for the work he outsources. So the question is, how do we get the time from the offshore team to be part of the improvement initiative?
Well, that sounds like a leadership issue. I mean, many teams have offshore teams. My experience has been that you've just got to figure out how to structure it so that that team is treated like part of the organization. Now, obviously, there may be some, if they're new, there may be some, they may be less experienced, they may need more guidance, but it's not particularly efficient to have an offshore team without the expertise not included in the mainstream efforts. And if all they're doing is bug fixing, I mean, or even testing, I know a lot of organizations just acquire resources to do testing. If they're not creating high-quality automated testing, then it's a fairly expensive proposition.
Okay. Jim, could you share some good goals and questions that you've used to measure a team's quality performance?
Yeah, one of my favorites is asking the question, what percentage of your defects are you finding and removing through peer reviews? And if you're either using a tool like SmartBear, you've got the metrics, or for some tools, for teams that are doing in-person reviews, we've just created a really lightweight tool where people just type in the following numbers: the number of defects found, the amount of hours of team effort, the number of lines of code covered, the name of the project, the version of the project, the component that was reviewed, the article that was, it's maybe 8 or 10 fields. We use both that data plus the code collaborator data to be able to answer that question. So that's a great question, because if the answer is, well, we do peer reviews, but we just don't measure them, you basically, my experience has been every team that's ever told me that, if you look at their actual output quality, it's not as good as a team that actually does peer reviews and measures them. I look at for automated testing, I look at the amount of code coverage measured with a tool like Bullseye, Clover, Emma. Basically, what line coverage, branch coverage do you achieve? How much effort does it take you to run your tests in days of effort? And a good answer is less than a day or even hours. It's amazing. I've seen teams where the answer is months. Basically, they invest, say, 20 people for 20-person days, 400-person days, 2-person years to run one test cycle. It's all about improvement. If that's the answer, if it's 400, then I would say to that team, what is your plan to cut that in half? Like in the, what do you think you can do? I wouldn't even set the goal. I'd say what can you do to dramatically reduce that number while increasing your coverage? Because of course you can reduce that number to 0 if you run no tests. So you basically are looking for how do you get higher code coverage with reduced effort, and over time you want to decrease effort while increasing coverage. Another great metric is this Net Promoter question. Go ahead and ask your customers, what is their likelihood to recommend the product to others on a scale of 0 to 10, 10 being highly likely, 0 being highly unlikely, and then ask the next question, what would cause you to be more likely to recommend to others in the future? And that's a great metric. Those are some of my favorites.
Okay, the next question is, should there be a sign-off process for the completion of peer reviews?
Well, the important thing is the team is motivated to want to, again, find an increasingly large number of defects early for the purpose of ensuring that they remove them efficiently and their customers don't find as many defects. And so I found if the team is motivated, then the team will usually hold itself accountable. So you don't need to have the author having someone check on the author. If you have to have someone check on the author, then you've got some other issues there. You really have to have a team, ideally, that trusts each other and is accountable and responsible for their own work. And when their peers point out issues, clearly people are going to be less keen to invest time in future reviews if they found that their peers are not doing the rework that they, fixing the problems that have been pointed out. If that's the case, then people need to hold someone accountable and say, hey, I gave you a lot of feedback on this, and I noticed that it didn't get implemented. So you want teams, not just manager to engineers, but you want engineer to engineer accountability. I remember one time, one team had set a standard saying that they wanted to peer review all their changes, and this person had done a check-in without a review, and the person said, well, it was only a small change. And then it was an engineer that said, hey, we didn't say we exempted small changes, and we didn't say we exempted your change. We agreed we'll do this. Let's get it done. So you ideally want the whole team holding itself and each other accountable.
Okay, the next one is a good one. How do you calculate the cost of writing the automated test versus the manual test, given the time you have in a release doesn't always allow you to have enough automated test coverage?
Well, when you say that it doesn't allow you to, it's basically a trade-off that's being made. If the decision is made not to implement automated tests, then the consequence is in the future, every time you do a release, you're going to have to test that functionality manually, or you're going to take risks that the functionality doesn't work. And so you're basically, it's like a credit card debt. Any code, any functionality that exists in a product that can't be tested with automated tests, you have technical debt. You have a bill that has to be paid every time that software gets released. You pay the bill in either doing the testing or you pay the bill in fixing the problems that customers find. So what we've found, and what I've found in many companies, is the average number of hours to find a defect when developing automated unit tests is about 3 hours per defect, which is still a bargain. It's still cheaper than finding the defect during system testing. So what's ironic is actually executing to a plan of creating, say, 70% automated test coverage actually results in many defects being found during test development automation. And you just automate this unit test while you're building it. There's a lot less point in writing a test that you just run once and throw away, that you've made the investment of writing it, now you're not automating. So what I advocate is, as part of development, part of definition of done, automated unit tests are created as part of that task. That in itself will actually save time in the current release. And then you have this future benefit of you have the unit test being the backbone of your automated test. In the future, they will find additional problems for you, and they will reduce the amount of effort required to do new releases. And so you keep, rather than having a cost, you have an investment that is actually having a payoff. It's the opposite of a credit card debt. It's like an investment account. Investments in automation pay off in the future. They actually save time in the future.
Okay, so Jim, I suspect you've dealt with change resistance in your career. So this question is, how do you convince the old-timers they're set in their ways to change them?
Well, that's why I suggest this viral approach, because you will always find there will be people in every organization. And the good news is, eventually, if you manage to flip those people, they will be just as dogmatic about doing this stuff. So they can be a great asset at some point. But initially, if you try to get everyone to do it, you will have them kicking up more noise and more resistance, and they will actually influence others not to do it. So by choosing first to work with the teams that are willing adopters, at least, now maybe not everyone, but if you can get the team to agree to do it, and they then have the task of convincing their own people to do it, if you can get teams signed up, then you end up, that's the best way to get these folks going. Now, the other way that's important is when we teach these classes, I teach a peer review class, it's only like 4 hours. I have every team bring their own code to review. We do a review, and then we go around to each table, and they actually, and that was the comment I read off, is this person was a skeptic, but they brought in their own code. I remember one situation where I had this team bring in code, and they were convinced that peer reviews wouldn't work, so they brought in production code, right? And the code, the name of the function was a function called getSize. It returned the size of a data object. And we found a defect in it. It had just one defect. Basically, it returned the wrong size, right? Now, they became believers because, wow, I mean, they came in total skeptics, but by just going through the process and finding a real problem, in like half an hour, they found a legitimate, major defect in a production system. This wasn't McAfee, by the way. They then, some of them at least, were flipped. I had another leader that came to me and said they don't have time for the class that we have scheduled. I said, why? And they said they needed to do a drop to QA. I said, well, please, bring the code that you're working on right now. And that manager and their 3 engineers found 4 serious problems in an hour. So one defect per hour for 4 people. And basically that was, he said, I'm convinced. You're right. It saved me time to go to this class. Even with the 4 hours of, the 4 hours total, putting 1 hour of an inspection, it was worth the time. So get people to do it, get them to try it, but don't push them if they're not even interested in giving it a go. Then find some other teams, and then over time, you'll get support from within the organization, and it'll become the bar will get raised to the point where people will feel very uncomfortable if they're not doing this because it's clearly working in other places.
Okay, I think we can get about 2 more in. So the next one is, what can someone do if they are not in a management position but would like to increase quality?
Well, there's a role for people, like I mentioned, this quality leader role. You can help the team establish its own goals. You can promote the idea of measuring some of these things. You can hopefully persuade the manager that this will be a good thing to try. You can persuade, hopefully influence some of the other developers on the team. You can get just a few to try it, get one project team. The good news about this is you don't have to have the entire organization do it. All you need to do is get a team, which is why I like to work with teams first, because over time the teams will move the entire organization. So that's my advice to you, is just find a team that's willing to give this a go. Now, I remember when I was an engineer a long time ago, I adopted this process with my team. I had a bunch of peers. I said, hey guys, here's an idea. Let's do code reviews before we check in. You know, I'll review your stuff and you review mine. And I was fortunate because when I was in college, I had a job programming, and my boss insisted that I review his code and then that he reviewed mine. And I learned how to write great code by reading great code. I learned how to make my code better through his suggestions, and I actually helped him from time to time. So that's all. It's just a matter of find a group of people that are willing to do this and go do it with them.
Okay, let's see. For the last question, does McAfee follow CMMI or any other process improvement framework?
We leverage many of the ideas from CMMI. We're not. We haven't invested in any certifications of assessments of what level we would achieve. And I'm a bigger fan. The thing about CMMI, it's a very useful framework for assessing how an organization's doing. I'm a bigger fan for not moving an organization at a time to a certain level as I am at moving a team, first teams, then teams within groups, and then groups to organizations, moving, again, more virally than across an organization.
Okay, so we're just about out of time. I'd like to thank Jim for all his expertise. I hope everybody learned something. I know I certainly did. It was really excellent. So we're out of time for the event, but the conversation will continue on Twitter, and you can participate in that using the hashtag McAfee Quality. So please feel free to do that. And I'd like to thank everybody for participating. And goodbye, and have a great rest of the day.